Hi everyone, welcome. Thank you for joining today's workshop on preparing for the new VCE study design. We know that there are some exciting and also slightly scary changes, but we'll walk you through them today. Before we jump in, I would like to recognise the diverse traditional lands on which we are each located. We acknowledge the traditional owners of these lands and we pay our respects to all Aboriginal and Torres Strait Islander peoples, recognising the elders past, present and emerging. Today's workshop will consist of 3 parts. First, with the help of our brilliant presenters, we'll explore the new study design. With the staggered implementation, this workshop's going to focus on what's in and what's out for Units 1 and 2. We'll be running a session next year to talk through Units 3 and 4. Today we'll also discuss tips for teaching and planning for the new cross-study specifications. Then I'll introduce you to our new series, Oxford Chemistry for VCE, and then we'll wrap up with a panel, a Q&A panel with our speakers. Okay, so we're very lucky to be joined by 3 fantastic speakers who, along with Carrie Bloomfield, make up the author team for our new Chemistry for VCE series. We've got Kate Adrians, who's the Director of Teaching and Learning Science at Frankston High School. We've got Carolyn Drennan, who is the Next Chemistry Education Association President. Congratulations, Carolyn.
I'm actually committee member.
Committee member. Sorry about that.
Sorry.
Yeah.
There's already one president already, but thank you.
Yes. She's also a ECCN committee member and a VC chemistry educator at Laylaw North Secondary College. And last but not least, we've got James Kennedy, who's a VC chemistry educator and director at Kennedy College. All right, so without further ado, I'll pass on to our presenters to talk us through what's in and what's out for Units 1 and 2.
So today we're going to talk through the overview of the changes. The new study design contains changes to the content, assessment and the cross-study specifications. And in the series, we'll be able to provide students and teachers with more help on those sort of things. So for Unit 1, what's in, we've got still have the elements in the periodic table, but we're introducing critical elements to this section. We've also still got covalent substances, including structures and representations. We've got reactions of metals, including metal recycling, which is a new element to that section. Reactions of ionic compounds remain mostly the same, but it also includes a bit about how precipitation reactions can remove pollutants from water. We've also got separation and identification of components of mixtures, including chromatography. We've also got the mole concept, or quantifying atoms and compounds. And for the organic compounds, we only have to learn up to C8 and the structural isomers up to C5. And there's more of an emphasis of the use of polymers and their applications in society, the variety of that we have. Because we used to know a bit about Kevlar and a bit about the protective coatings on saucepans, but there's a little bit more to it than that with the advent of new technology. What's out? The nanoparticles and nanostructures, which also used to be a standalone section in the old investigation topics. The Bohr model, which we've done in Year 9 and Year 10 to death, that's gone. The extraction of metal ores used to be part of the metal bonding part, but that's now gone. Same with the metallic nanomaterials. The emphasis on crude oil has gone as well, but that's still covered in Year 10 and for some in Year 9 as well. Cyclic compounds, the more advanced cyclic compounds with 9 carbons and 10 carbons, and the structural isomers for carbons 6 and 7 carbons, they're all gone as well. So the VCA have made a concerted effort to try and reduce the content. So that's why all the what's out ones are gone.
So for Unit 2, it kind of looks similar to what we have already had. Water's pretty much the same. Acid bases, we've got antacids are in and applications to society are in. Unit 2 has this huge focus on applications to society, and the end of Unit 1 with polymers there. Redox reactions, again, with the application to society, and then that goes, as we know, in 2, 3, 4. Measuring solubility and concentration, and precipitation reactions come in here again, which it was a bit exciting for me personally. To remove impurities from water, analysis of acids and bases, really similar to what was already in there. Measuring gases is down from year 12 or 3, 4. So that gas stoichiometry, get them going early on that, and analysis for salts is in as well. What's out is applying solvent properties, for biological, domestic and industrial contexts. AAS is out, which I was completely devastated about. And I know most of you won't be with me on that one, but and organic contaminants is out, which we might not be so devastated about, but it's gone.
Okay, so in terms of the changes to the assessment, for outcome 1 and 2, you need to select at least one task from the specified list, and the same task type cannot be used more than once across unit outcomes 1 and 2. That's due to the repeated reports of from VCAR about every school that's audited will tend to use test, or a prac report for every outcome for those 2 units. But now they're specifically stating that you need to change it up, and we'll provide some more support through the textbook. For outcome 3, there's a response to a question involving the production or use of a selected material, including reference to sustainability. And sustainability is one of the core new content areas that have been introduced into Unit 1 for this study design.
So the changes to Unit 2 assessment are, like Carolyn just said, that it's one task from a list and the same task can't be used more than once, but it's a huge list. There's heaps to choose from. And in the book, we're really helping address those and see what kind of different things you can use to assess. And then outcome 3, which used to just be a poster, is now a selected format, kind of, however you want them to present it. So poster, oral presentation, report, multimedia, huge amount, but I know personally I'm going to stick with that poster, and we've put heaps of that into the book, just all about how to do the poster, but the other things as well if you wanted to change it up. But I know we like to mimic Unit 3, 4.
Okay. So speaking of the poster, this is what it looks like for Unit 4, Outcome 3. But if you're like Kate and myself, we tend to try and challenge the students to do this at year 11, and in some cases, for some schools, they like to do it in year 10 as well, just to get them practice to the format. In the book, we actually go through a very detailed explanation of what's involved for each of those section headings in the poster. So what's on the left-hand side of this slide is just a brief summary, but the communication statement is a new thing that some of you have already seen from the the biology study design. The communication statement has to be 20 to 25% of the poster space, and it's one sentence. That's it. Everything else has to fit around. It's very tight. So you also need to possibly give the students some skills to make sure that they present everything in the shortest possible number of words as possible, because the word limit's changed. It's not 1,000 now, it's 600. So again, in the toolkit, we will be providing more explanation of all these poster sections. So the changes to the cross-study specifications for Unit 1 and 2, we have key science skills. It's a continued push from the last study design. The new sustainability is the new one of the new ones. We've got critical and creative thinking and ethical understanding. In chemistry, that has not been an emphasis as such in the previous studies design, but it is becoming more of a focus. And we actually, again, in the toolkit, we provide extra information on how to structure that and give the students extra information, because there's only certain topics that can do that. And normally it's in humanities that they've done, or English, but in science and especially in chemistry, they've got to actually be able to be assessed on that, not only in the junior years, but it's more of a push in the senior years to make it more explicit. The individual and collaborative scientific endeavour, that's always been in chemistry. The Aboriginal and Torres Strait Islander knowledge, cultures and history is one that has been focused in year 7 to 10 in the past, but now there's a push to get into VCE as much as possible. And also the range of scientific investigation methodologies that can be chosen to meet the outcomes has increased significantly from the previous study designs to date. And we will provide students and teachers with more support through the textbook. These two ones that we're talking about today, the key science skills, sustainability, the Aboriginal and Torres Strait Islander college knowledge, cultures and histories, and the investigation methodologies is what we're focusing on in today's presentation. So now we're getting to the tips for the planning. So with this key science skills, some of you may recognise the diagram on the right. It's from one of the old advice for teachers, but we've just modified it slightly to include communication, because as well as being able to do the research question, the aim, the method, procedure, the data collection and analysis, and also the evaluation and conclusions, you need to be able to present it as a suitable communication, because you need to be able to talk about or present your results so that other people can reproduce what you've done to verify that your experiment. So in the textbook, we are pushing for more headings for this, and I do apologise, they're testing out the sirens in the school because they're not working in the science area where my office is. So we will be able to provide students and teachers with more resources to help them develop aims and questions. So all of those headings, all of those headings on the left-hand side, we have separate sections in the chemistry toolkit that provide more support for the students and the teachers on how to get those done.
So sustainability, like we've been saying, is huge in the new study design. It's the ability of students to apply, analyse and evaluate and communicate scientific ideas. It's one of the key science skills, and it's applying sustainability concepts to pretty much all topics, but there are specific ones that it really relates to easily. So in the VCE chemistry study design, sustainability is considered in terms of 3 perspectives. We look at sustainable development, the goals from, oh, I've forgotten who they're from. It's on the next slide. The green chemistry principles and a move from the linear to a circular economy. And after a huge amount of emails personally with me and Maria James, we really put it in as much as we could and double checked with VCAR that we were getting it right and what they wanted. So the Sustainable Development Goals are 17 goals that address current global challenges as a part of the 2030 Agenda for Sustainable Development. And while chemistry is involved in all 17, there's actually 9 in particular that are relevant to the study design. From the UN, thank you. Whoever just put that in the chat, from the UN, it is. And I taught environmental science last year, so I should have known that, but slightly nervous. So the first, the ones that we look at specifically in chemistry are zero hunger, which is goal 2. Goal 6, clean water and sanitation. Goal 7, affordable and clean energy. Goal 9, industry, innovation and infrastructure. Goal 11, sustainable cities and communities. Goal 12, responsible consumption and production. And that's one that I've really looked at, writing the polymer chapters and organic chemistry chapters. Goal 13, climate action. Goal 14, life below water. And goal 15, life on land. So if we zoom in on a couple of these goals, you'll see that you can get these from the UN website, and you just type in Sustainable Development Goals. Goal 12 there, we have huge links, like I said, in polymers, but also in fuels. And goal 14, life underwater, life below water, has big links to salts, water and acid bases. And we've made sure that they're really clear in the textbook. So then the next one is the green chemistry principles, and these pop up a lot as well. These are pretty much all about considering how to be better chemists, and we can pose those questions to students as they go through the chapters. So how do you have no waste? How do you have no harm? How do you have renewable processes, and how are you a thoughtful chemist? So we look at just 7 of these specifically, although obviously all 12 are relevant to chemistry because they are the green chemistry principles. We look at atom economy, catalysis, design for degradation, design for energy efficiency, designing safer chemicals, prevention of waste, and use of renewable feedstocks. And there are huge links in these in organic chemistry amongst the other topics. But as you probably noticed already, I'm big on organic chemistry, so that's where they are. The last sustainable development or sustainability that we're looking at is linear and circular economies. So that is moving from a linear economy, which is mostly our current economy, to a more circular economy. And these appear in the study design, but it's all because resources are at risk of becoming scarce due to our growing global populations and rising prosperity levels. We all want more stuff. So how can we turn that stuff into a more circular economy? So the big questions that you can make links with your students is, and that we do throughout the book, is how do you go from the current linear economy to a more circular economy? And this pops up in heaps of chapters, but mostly in fuels, polymers, metals, and again, organic chemistry. Over to Carolyn for the next part.
Excellent, thank you. Okay, all right, so for the Aboriginal and Torres Strait Islander cultures, knowledges and histories, this is an optional investigation topic 3 in Unit 1, Area of Study 3. So we are providing support for teachers if they choose this through the chemistry toolkit. So we have the toolkit which basically takes every part of the study design in more detail and helps the students look out for more resources. So we've got some links from the Queensland Museum, from ACARA, from the Australian Council Deans of Science, and the Conversation to help. And included in those links are relevant articles for medicinal plants, and what plants and pigments are used for paints and additives, and which ones have been used for fishing practices and also to make glues and adhesives, amongst others. There's also a few references to the superfood of kakadu plums as well. So at the end of the toolkit that we go into the Aboriginal and Torres Strait Islander cultures, knowledges and histories in a bit more detail.
I'll jump in here. Great. So we talked about audits. I know that we talked about testing. Caroline, I mentioned, I'd written down here, she said test, which does happen, unfortunately, too often in many schools. And, you know, when the audits are required to be done, it's usually exposed that they've done too many tests. And it has come out in the new study design that there are now 8 different types of assessment which need to be done. And I say need to be done because you can only do one of them once, and then you have to diversify. But the list is here, and you'll notice that actually only one of them is a traditional prac, which makes it interesting. So that's controlled experiment, and the others are really quite different from what we would be used to. So something like simulation is now in the list. You can use an online simulation platform and have, you know, a structured task within that platform. This can be done asynchronously or for students in isolation, for example, and that can be an assessment. So this can be quite challenging, obviously, for teachers who are not used to doing things that are not particularly, you know, tests or the structured lab reports. But we've got everything covered in the upcoming book, right? So we've actually covered all 8 so many times over, roughly in an even distribution, so you will not be short of ideas. And they're basically ready to pick up and go. So it's full of ideas. I forget how many we've got in there. It's a lot of all 8 types. So I'm just going to show you 3 of those. They're actually in the book, but it's a very quick overview of what you'll find in there. First one is helium. Now, I should actually add that all 3 of these are tried and tested. These are not just ideas we came up with. These have actually been done in the classroom and they've worked. So the helium one is because, I mean, who doesn't love balloons? Everyone's familiar with it. And when you tell students that we are running out of helium, that it's going to become endangered within 100 years, there's this sort of mixture of shock and intrigue. And then they say, well, we shouldn't use party balloons. And then yes, absolutely. And it instantly sparks this interest. And you're halfway there already then with motivating them to get on with their research tasks. So the Helium one has worked really, really well for me. And I actually ended up in the last few years getting everybody to do it by video. Even for when we were face-to-face in the classroom, the video worked better because I had a few students with issues with speaking in front of the class, I think induced by COVID, potentially, or exacerbated by that. And they wanted to do a video, even though we were physically able in the class to do it as a presentation. So the video task worked well. The quality of the video is actually better than the quality of usual spoken presentations, because when you record a video and it's strict cutoff, you can choose 2 or 3 minutes as a strict cutoff. They end up having to do it so many times before they get it right in one take. So they learn more. They've actually practiced it more times, so they learn more from it, and the quality is better when you come to market. So I strongly recommend do it as a video. There's the structure of the questions. There's much more in the book, but for that, I'll go to the next one. So this one has worked really well as well, and this one can be done face-to-face. It can be done asynchronously, but I honestly recommend doing both. So what this is you build molecules using either the plastic molecule kits, the Snatoms, or the other ones, the small ones, or use the online tools. So Chemmagic, this will be in an upcoming slide. Chemmagic or Moleview are great for doing a hands-on modeling, the equivalent of plastic atoms. And in some ways, the online, the web-based molecular modeling kits are actually better. You don't run out of atoms for a start. You can quickly tidy up and reset. You can view existing molecules from the library. Yeah, there are several advantages, and you can do it at home asynchronously too. So these molecules here, there are 12 of them they have to build. They then have to draw them correctly, label the shapes and the angles, classify them as non-polar or polar, and predict their solubility and their state of matter. This is all well structured as a big task, as a classification identification task, which I don't know if you remember was one of the types of assessment. And these 12 types of molecules are chosen extremely carefully. So the first few, water, ammonia, and ethanol, form similar types of intermolecular bonding. And to answer the question in the chat, yes, it's on an upcoming slide. You can jot them down in a minute. They got the spelling there. Methane, chloromethane, dichloro, and you can see the pattern there with the methanes and the chloros. You eventually get to a point where they become more and more polar. Tetrachloromethane is non-polar. Students need to understand that. Ethene and hydrogen chloride again. So there's a pattern to these, and in sort of 3 categories, and each one is each molecule is designed to teach students something that is very important in this topic. I'll show you the third one as well. 6 white powders. Now, I don't know if you've noticed, I'm from the UK, and this was by the way, in the UK, we do an externally assessed prac at the end of year 12. So this was my externally assessed prac. The examiner comes to the lab, and we have to do an individual prac. So it's a surprise prac as well. They don't tell you what it is until you walk in. But this was mine, and I loved it, and it stuck with me. 6 white powders, and there's lots of drug jokes as well. The students will do that among themselves, but they get really into it, partly for that reason. And you have to identify what they are. And obviously they say, oh, one of them's sugar. Yes, probably. One of them's salt. Probably. Can you eat them? No. And they get into it instantly, like the Helium one. These powders as well, by the way, are chosen very, very carefully. They're cheap. They're relatively safe. Every school will have them. But also, it allows you to use those 5 tests on those 5 bullet points. So the solubility test will expose one of them as being insoluble. Conductivity of aqueous solutions will expose another one. Observing the color change on the addition of water, that exposes another one, the copper sulfate. Reaction with acid. There are only 2 of them react with acid, but then you've got the flame test to distinguish between those 2. And the beauty of this one is it can be extremely difficult. So basically, I got not much more than this slide in my assessed A-level prac, but you can scaffold it for students who need more support if you want to. I'd recommend at the maximum scaffolding level, you could have 3 checkpoints where students first have to rewrite a method where you would carry out these tests in this order. Write a reasonable method, write down the safety, etc., have that checked, and then they have to make predictions. Maybe they formulate the method as a flowchart as well, then to make predictions about what would happen in each case. They have to look that up. It's a take-home task. They then get that checked. They then have to actually do the experiment, or asynchronously, they would be given the theoretical results, or even a video. right? You could even make a video of this as well. But this can be done asynchronously with modification, and we've got details on how to do that. But like I said, for the students who don't need much help, you could give them not much more than this slide, and they will be able to figure it out. It depends on your cohort. It's highly flexible. All right, and that's really fun, that one. So these are the alternatives. This is the slide where it says Chemmagic and Moleview. They're the two tools I found that are best. They're the alternatives to the plastic modeling kits. If you can, get Snatom's X. I actually really like those. They're the big fat atoms. They're massive and they're magnetic. So they're the ones I use. But yeah, the modeling kits or the online modeling kits. And like I said, they're not alternatives. They're not mutually exclusive. Like, use both if you can. So I've even had students in the classroom using the online Chemmagic because you learn things from that you can't from the kits so easily. So do both. Helium works really well, done asynchronously, no modification required. Obviously the prac, yes, they're expensive, aren't they? Snatoms. The 6 white powders works really well, but you have to make huge modifications, and it's highly flexible. You can scaffold that 0 or 100%, and this is all nicely laid out for you. So if anyone has any questions, let me know at the end. But these are all tried and tested, and these are my favorites. I brainstormed a lot to give you these today. So, all right, let's move on.
Cool. Those are some really helpful tips. So thank you, Kate, Carolyn, and James, for giving us an overview of the changes and for those tips. With all of these changes in mind, Oxford's publishing a new Chemistry for VCE series structured to take the worry and stress out of planning for and implementing this new study design. The series is mapped to the new content, provides support for assessment, and we've really tried to help you out by building in these cross-study specifications. This is what they look like, and today I'll give you a quick tour through our sample chapter for Units 1 and 2. Alrighty, so each chapter is directly mapped to a section of the VCAR study design. Chapters are then broken down further into topics according to each individual key knowledge dot point. All of the dot points for each section are included within the chapter openers, and in the case of covalent compounds, we've got 6 key knowledge dot points, and they correspond to 6 topics within the chapter. In this chapter opener, you can also find groundwork questions. These help to make sure students understand any prerequisite knowledge before they jump into the chapter. So if they find that they're unable to answer these questions, they can access digital worksheets via these icons to increase their confidence before they go in. You also find a list of practicals for each chapter. Across the whole book, we've made sure to cover all of the 8 scientific investigation methodologies, as James emphasized earlier, in order to help you complete the 10 compulsory hours of prac work per unit. All right, diving into a topic, you'll find that each starts with key ideas. These are succinct concept statements that summarize what the students will be learning in each topic. Glossary definitions can be found within the margins and also at the end of the book, and experiments appear at the back of the book as well, but in order to help maintain the flow of ideas, that's why they're signposted here, so it's a bit easier for you to navigate. We've also got study tips. These provide students with important things to know, mistakes to avoid, and any tips that might help them prepare for exams and assessment tasks. Worked examples also appear within the chapters for questions that students may encounter in the book or in their exams. And every worked example is accompanied by a video demonstration, which walks students through the thinking process and how to apply that to an actual example question. Another feature is the challenge. This provides students with the opportunity for extension. So it's an opportunity for them to practice critical thinking skills and apply their knowledge. We also have these real-world chemistry features. These connect the chemistry content to real-world examples. We don't really see this here with covalent compounds, but say for the polymer chapter or organic compounds chapter, which Kate mentioned earlier, sustainability is certainly built into these real-world chemistry features. As we all know, there's that continued push towards key science skills, so we've made sure to include more opportunities for students to practice these skills in context of the chapters through skill drills. Here we've also specified the key science skill that the skill drill relates to and any specific pages within the chemistry toolkit that can help provide support for students if they do need it. Each topic then ends with a check your learning box with lots of questions for students to apply what they've learned in the topic. We've reached the end of the chapter now, and we've got a chapter review. This includes a chapter summary, bringing together all the ideas from each topic. Where relevant, here's where you'll also find any key formulas relevant to the chapter, and also chapter checklists. These encourage students to take charge of their own learning by assessing themselves against success criteria. If they're feeling confident, that's great, but if they're feeling a bit unsure or really unsure about the content that they've learned previously, they're directed back to the topic that they should revise. Now, we've talked to lots of chemistry teachers and you've told us that you want more questions, so here they are. Chapter reviews include upwards of 30 questions per chapter, including multiple choice questions and short answer questions. Students will also be able to access digital Quizlet question sets and chapter quizzes to test their understanding. But if that's not enough, we have even more. Area of study checkpoints and unit reviews provide even more opportunity for students to engage with exam style questions so that they're as prepared as they can be once they hit year 12. As I mentioned, experiments are at the back of the book. We've included a range of prac options for you to select from in order to satisfy that 10 hours of pracs per unit. And we've covered all of the 8 scientific investigation methodologies. Each prac also comes with a demonstration video, editable worksheets for students to use, and lab tech notes and risk assessments with general advice for running the pracs. These will all be available via our digital platform, which I will give you a really quick walkthrough now. Here, I've just got the home page for the Oxford digital platform, and you can find the book here. So I've just got the sample chapter for the teacher version of the book loaded up. You can click here to access the ePDF, so I'll just click through. And this is the covalent compounds chapter, which I've just walked you through now. You can flick through the pages using these arrows here, or you can navigate using the book content tab where you can just flick and directly go to the topic that you're looking for. There are also note-taking, highlighting, bookmarking, and a dictionary functionality that you can access. The resources for each chapter and each topic are found within this resources tab at the bottom here. And each topic is structured to be 1 to 2 lessons. So we've supplied teacher notes to help you plan your lessons. If I open this up, you can have a look. So you'll be able to find any key information like key knowledge, success criteria, key terms, as well as suggested activities and also some advice for differentiation. So I think that's quite cool. Student book questions, including all the challenges, skill drills, real world chemistry, check your learning, and so on, are available as editable PDFs for students to type their answers in or print out. At the moment, they're not editable, but when you get access to them later, they will be. Answers for all the student book questions are available at the back of the book, but in addition to this, where questions may have quite detailed working out, we've provided worked solutions as well. So you can access that through here. You'll also find auto marking digital quizzes for each topic. I don't have time to show you these today, but we'll be having a full product walkthrough on the 14th of June. So if you're interested, I'd encourage you to come along to see the whole suite of resources that we have to offer to help support your teaching. You'll be able to access any relevant web links here, as well as those resources attached to experiments, like the experimental worksheet, which will also be editable like this, as well as risk assessments and lab tech notes. So I'll just give you a quick look at these. Yep. Okay. I'll just switch back to the presentation now. Right. So again, this has just been a really quick walkthrough, and I'd encourage you to come along to our full product walkthrough on the 14th of June. In terms of pricing and availability, you can find this information in the following table. Units 1 and 2 will be available later this year, and 3 and 4 term 2 next year. Complete print and digital samples for Unit 1 and 2 will be available at the end of term 2 to help with your book listing decisions. Also, just wanted to note that the student digital licensing period is 2 years. So after year 11, if students will still have access if they need to go back and fill in any gaps in their understanding that they find when they're working through the year 12 curriculum. So I think that's quite handy. All right. Before we move on to Q&A, I just wanted to introduce you to our sales team. We've got Alicia, David, Caitlin, and Paul. Okay, so now that that's done, we're going to move on to the Q&A. Have we got any questions in the chat to start us off?
Hey, Elena. We do have a
Yes.
few questions. I'll start from the start. Okay, so Angela has asked, are ethics included in the poster?
I can take that one. Yes, ethics, discussion about ethics is also included in the poster. You can talk about that in the discussion and evaluation part. And but with we've actually talked about ethics as a separate heading in the chemistry toolkit, and we've defined it, and there's certain questions that students can ask of themselves as they're collecting their data that meets the ethics process.
Also in the poster and investigation chapters in both the 1, 2 and 3, 4 books, we address it there with questions. Again, like Carolyn said, the students can ask of themselves and places they can go with the ethics.
Perfect, thank you.
Thanks, Carolyn. We have another question from Sharon. Is there consideration given to the use of chemicals in experiments, and particularly the disposal of their afterwards?
Yes, when the risk assessments have completed, that will be well considered. Yes, we'll be providing some direction. But on that one, mostly the normally local regulatory bodies you'd be referred to, but we will definitely provide advice on which ones are can be disposed of off-site and which ones can be disposed of within your vicinity at school.
Okay, great. And we had a question from Kelly Ann about the books being ready for purchase and evaluation, but I think you guys have covered that with your slide before. And then there's another question from Joshua. So is the chemistry toolkit an online resource for the students and teachers, or is it a separate chapter within the book or a separate purchase?
The chemistry toolkit is part of Unit 1, 2 and also the Unit 3, 4 textbook. So there are standalone chapters going through each of the parts of the VCAR requirements to actually complete the VCE course. And that's one of our features, because we've noticed that there's not of other publishers that do that in quite so much detail. So we made a deliberate effort to do that.
And it's chapter 1 in each book, and Carolyn worked super duper hard on those. I know that, yeah, banged their head against the wall in a lot of emails between us. So
because so there's about 12 sections in the Unit 1, 2 book, but because 3, 4 is there's a lot more prerequisite knowledge required for 3, 4. It's actually 14 sections. So the chapter 1 in the 3, 4 book is 14 sections.
Great. We've got another question. So what topics in year 11 are the ones to focus on or will feed into year 12?
that's a James question.
Moles, obviously. We have actually the slide of what's where is it? There was that slide we had earlier of what's in and what's out of Unit 1 and 2. But yeah, typically organic moles. I'll have a look at the slide for the rest of it. Organic moles, like it's yeah.
I full
sustainability is
handled
a
that
main
one
thing
as well.
That's more of a, that's not a content thing. It's more of a way of thinking. But sustainability is the key theme throughout all of the units 1 to 4. But yeah, organic redox as well. Yeah,
Yep. It
redox.
goes through.
Yeah.
I know we had this conversation last week and I don't think any of us wrote it down, but there are definitely the dead end topics and the ones that continue through.
Yeah.
Yeah, I also can't remember.
I mean, they all need to be taught. They all need to be they all need to be taught, assessed, and learned. But obviously, you do change it. You help your students as much as possible for next year. Obviously, by spending more time, if you have it, on models and redox and organic. Yeah.
Yep. And
Organic.
Then, of course, the other thing is too, some of those other chapters that are not covered in the 3-4, they need to be taught in year 11 because they can appear in an exam question at the end of the year in a different context. So it's all about, so the year 11 is the foundation year, it's all about the knowledge, but the application of that, because the VCAR exam is a total exam around units 1 to 4. So some of the things that we consider as dead-end topics, like ionic compounds, can actually reach an exam question in a different context where you have to recall the solubility rules in order to answer that appropriately.
Yeah, there was that rate equilibrium question where you had to draw the graph and it was silver chloride. It was the definite precipitation reaction one. I could not tell you what exam question number that was, but it popped up a few years ago and I know the kids just went, what does that do? You're like, oh, yep, removes it because it's precipitation. So I push that when I teach precipitation reactions. Like we may not definitively talk about this again, but it definitely is something you have to retain.
Perfect. Thank you.
Okay. So we've got another question from Kellyanne. Are there online quizzes or questions that we can use to track students' progress?
Yep, so this was my bad. I was meant to walk you through that as well. So I'll just quickly share my screen again and show you. So hopefully you can see my screen there. Is that okay? Yep, perfect. So for the tracking progress, we've got this reports tab within the Oxford Digital Platform. And what you can see from there is if you select your class, you can access these curriculum reports. And once it loads, we'll see. All right, so we've just got a bunch of students loaded up here. This breaks down the book into the area of studies, so you can drill down into that area of study to see how students are performing. You can also drill down into the chapter level, so this is the covalent substances compounds chapter. And then you can also see down on the topic level how students are performing on quizzes. So I think this answers both Kellyanne's question and also Joshua's question, which I see a few comments down. Quizlet questions, Quizlet questions and also chapter topic quizzes, chapter and topic quizzes, they're different from the ones that are supplied in the book. So these will be digital only questions. Yep, so we've got extra question sets for you and these will feed into this curriculum report that you see here. So I think that's quite handy. Yep. I hope that answers those questions.
Thanks, Lena. So we've got another question from Hanifa. Sorry if I'm saying that wrong. But is there exam style questions provided? Wording tends to differ from textbook to exam or go across chapters.
Yes, we do exam style questions. They are in the, Alina, correct me if I'm wrong, the unit reviews?
Yes.
Yes, they're called the unit reviews. Yeah, so many different names for things that I continuously forget. Apologies. Unit review is at the end of unit 2, the end of unit 3, the end of unit 4, and the end of unit 1, which is odd that I forgot 1, and is an exam style question. We also have at the end of each chapter in the 3-4 books and in the unit reviews in 1-2, like mark like an examiner and think like an examiner. I think they're called think like an examiner sections. where we walk through VCAR questions, do a worked example, a good example, a bad example, and show the students how to answer those exam questions well. So they definitely, using the Oxford book, would get a view of how exam questions look. Yeah. Carolyn, did you want to add to that? Sorry.
Yeah, just the end of unit review tech point questions too. They're set out with multiple choice and also extended response questions, but they're more of a higher level question rather than just. So at the end of the chapter, you'll have the bell curve type of questions where most people can answer 60%, and then the 20% for the higher, 20% below and 20% above that bell curve. But definitely for the checkpoints at the end of unit 1, 2, 3, and 4, those will have the exam style questions there.
Yep, I just wanted to jump in there as well. Firstly, I think James might have to head off.
Yeah, that's
Is
right.
that
But thank
correct?
you, everyone.
Yes.
If you have any more questions that that only I can answer, if that is the case, just email me through and I will respond.
Yep. I also just wanted to say thank you again for presenting today, and yeah,
That's
we're really
wonderful.
happy to have you.
Thank you. I'm very proud of this book, by the way. It's been a lot of hard work and it's looking absolutely fantastic. So thank you very much, everyone.
Perfect. Thank you. With regards to that last question, I also wanted to add that we've also got those chapter review quizzes online on the digital ones. Those are also going to be exam style multiple choice questions. So we've given students lots of opportunities to engage in exam style questions ahead of those exams. Yep.
Thanks, Lena. So we've got another question from Kellyanne. So are gases examinable in Year 12 when evaluating fuels?
Yeah, so thanks, Kellyanne. Again, so many questions. The gases they come back up in Unit 3, right near the start. The heading is measuring changes in chemical reactions, and it definitely assesses gases in there. I think perhaps in the organic fuels chapter slightly as well, but gases for sure come up. If Kerry were here, she'd be able to know exactly where all the equations are. But she couldn't be here with us today. She's the fourth author, not the fourth, but she took those chapters, so she'd know for sure. But it definitely comes back up in Unit 3 again, so it's assumed knowledge by that stage, but in the book again, and worked examples for students to go through.
And can I just add in there, we also specify particular formulas that are important for those chapters, especially for those ones that involve a lot of maths. We actually specify the important formulae that need to be known by the students before the chapter review questions. I thought that would be one to put in there.
Okay, great. So we don't have any, I don't think we have any more questions from the chat that are outstanding. Unless there were any last minute questions that wanted to be thrown out to you.
Everyone's happy?
It feels like remote teaching again. Like, come on, good bells, any questions? Just kind of sitting here dancing, waiting for everyone to answer.
Alrighty. Well, if we don't, I'll just share
Ollie.
this.
We got a last.
Oh, we've got something?
Yeah.
Oh, well, I'll keep this up, but yeah, let's ask the question.
So do you have any fieldwork suggestions?
Ollie, you'd know that off the top of your head, wouldn't you?
Yes. So you can find them in the book. Yes, you can find them in the book.
There are definitely specific examples of all 8 of the in the book. So it's a great book. I say buy it, but book list it. I'm biased though.
Yeah, and we've got another book listing or book hire question here. So how would Oxford support book hire schools? That might be one for our sales team to get back to.
I think so, yeah.
Okay, and then Angela is asking, how can we view the book?
So in terms of the digital sample, so the full sample for the covalent compounds chapter, you'll be able to access that at the end of term 2. So keep your eye out for that. Any information should come into your email inbox, and also if you register through that link that Stephanie has kindly provided just now, you can stay up to date with any news and get the register for that upcoming walkthrough. Yep, so that's a good segue into this slide here to save the date for June 14th for that full chemistry for VCE product walkthrough. So I'll be giving a much more in-depth overview of our resources there. And in addition to this, just keep an eye out in your emails for a link to request your PD certificate. So there's that. Where is the June 14th walkthrough? It will be online. Perfect. Yep. If there are any last questions, I'll give you 30 seconds to to put that in the chat before we call it here today.
Oh, we finished early. Excellent.
Got some thank yous.
No worries. Thanks
Yep.
for coming, guys. I hope you liked it.
Yep,
Like Jane
also,
said, if you've got specific questions for us, feel free to email them to Oxford and they can pass them on to us. Or if you find our emails on the education, I think that works somehow, feel free to email us that way as well. We have really gone through this study design back to front now. So I'm already kind of thinking about it as I teach. I'm like, no, stop. Oh, hi, Dana. So I keep talking about sustainability in class. I'm like, no, you don't need to know this yet. Sorry, this is just for fun.
your
Thanks,
scaffolding. Yeah.
everyone.
Yeah, I also
Thank
want
you.
to add, because everyone's saying thank you, that I wanted to thank you guys for giving your time to present today. The tips were really helpful. I thought the session was really good. So great work.
Thanks.
And thank you to everyone for attending today.
We'll see you all at the walkthrough.
Mm-hmm.